Hello and welcome everyone. My name is Mark Henry, and today we're going to be talking about how to improve your network performance by 50% every month. This is a version 2 of this presentation. We did an earlier one, or we recorded one earlier this year in January. So if you participated in that one or you've seen it, the recording online, there are some improvements on this one as well. So a few bits of housekeeping before we get moving. Everyone, all of our attendees, we have a lot of attendees coming in today, about 65 people. So you're all going to be on mute. Again, that's really just to prevent background interruptions, feedback, background noises, that kind of stuff. If you do have a question during the presentation, please use the GoToWebinar's chat panel. We do have a couple of participants on the Opmantic end here who will flag me down, read through those, and we'll try to address them as you post those questions out. So feel free again to use the GoToWebinar chat to ask any questions during the presentation. If you'd rather not ask during the presentation, when we get to the end of the presentation, we'll turn off the recording and we'll open up a Q&A session for everyone at that point. We'll also take everyone off mute at that point. So if you have a microphone and you want to ask a question verbally rather than written, that's fine as well. A copy of this recording will be made available to everyone after the session today. You'll get an email with the download link so you can view it online. A paper copy or a PDF version of the presentations also available right now in the GoToWebinar handouts panel. So if you look in the handouts panel on your GoToWebinar control piece, you should be able to download a PDF version of today's presentation. Once again, this session is being recorded and it will be made available to all of the attendees. We also post these out to opmantic.com under the Learn section of the website. So if you go to our blog area, it's just called Learn. You can go there. You can see all of our past sessions. You can watch the videos. You can download content like the PDFs, or if we use an Excel spreadsheet, you can get all of those types of resources directly from opmantic.com. That's opmantek.com. So what are we going to talk about today? First and foremost, we're going to talk about how to remediate your network events to reduce background noise and load on your network. So that's a key piece. That's going to be the bulk of today's discussion. We are going to touch on how to use Opmantic's Opie Events product to do event automation and troubleshooting and repair. We're also going to touch on Opmantic's Opie Trend product to talk about how to use Opie Trend to replace the NMIS static thresholds and help you reduce false alarms and false alerts. We're going to talk about how to monitor configuration changes using Opie config and how that will help you move forward towards more reduced downtime in your network and less impacts on your network time. So we're going to get started. First question I always like to ask is why? So why are we talking about improving network performance? And there's really a good sized sampling of causal factors, right? And the first might simply be just poor network design or architecture can lead to congestion. I've worked with lots and lots of different businesses over the years and often run into situations where the team that's in place now, the network was actually designed by a predecessor, by someone who had previously been at the company and perhaps either moved on to a new position at some other employer, or they'd moved up in the food chain and the architecture itself had been stagnant for a while. No one had been keeping up with usage of the network and keeping track of how application usage is shifting, internet usage is shifting, and making sure that the overall network design is keeping up with that. We often see a lot of situations where there is insufficient hardware, meaning CPU or memory or bandwidth capacity as usage grows. And that doesn't necessarily mean that a company has to add a lot of employees, but in many cases, as applications move from desktop to server or from internal server to outside data center or even to a SaaS solution or cloud delivery, keeping track of the types of hardware that you need and where your loads are across the network. And of course, that feeds in, of course, to part of the overall network design and architecture. An item that I think doesn't get looked into and considered often enough is poor cable selection. People using older versions of the Cat6 cable, using unshielded twisted pair cable rather than shielded twisted pair cable. Granted, the costs are higher. Also, poor cable installation, poor cable endpoints being done and endpoints not being tested for quality of connectivity before cables are installed. So, if you don't have good cabling, if you don't have good connections between your points, then of course you're going to have all kinds of issues with high error rates, drop packets, slow data transfer, lots of repetition that can really negatively impact the performance of your network. And a fourth piece, and this is just really a small sampling, right? This list could be 15 slides long, but these are really the kind of the top four from my experience base. And the fourth one is unauthorized user activity. So it's not just the authorized applications that are eating up your network bandwidth. It's people who are on Facebook all day. They're on chat servers. They're watching movies on Netflix or on Amazon Prime. There's P2P file sharing systems. All of these types of unauthorized activity on the network, of course, adds load to your hardware in the form of memory usage, in the form of lowered availability and bandwidth capacity. So before we move on, what I'd like to do is I'd like to ask a quick question for everyone. And throughout the day, or throughout this presentation rather, I'm going to be posting various little quick polls. So if you could take just a moment, read the poll question, and you can, for this one, you can select one or more of the following options here. But which IT standards does your company adhere to? And those could be ones that your company says, hey, we absolutely follow COBIT, or we're invested in ITSM, but maybe they don't follow it 100%, or maybe they apply what they can of it. Just pick the ones that you guys are using, and however you want to define that as things that you're actually really heavily invested in, or things that you're kind of dabbling in or looking into. So we're going to give this another 15 or 20 seconds here. All right. Thank you all very much for replying. Strangely enough, it looks like the replies are pretty evenly spread out between COBIT, MOF, ITIL, and ITSM, with no one using the older business process framework of ETOM. All right. So one of the things that Augmantic really focuses on is a combination of ITIL and ITSM. So IT Service Management Model actually consumes and uses a lot of the kind of the original UK ITIL specification in the way they define their different levels of performance and value to the organization. When you start looking at remediating, proactively remediating the performance of your network, looking at it on a day-by-day basis and working to improve the quality of the experience and the stability of the network, you're really moving yourself up much beyond a level 1, even a level 2, and heading into a strong level 3 services level. Again, this really depends on, we're gonna cover a process in a couple minutes that we recommend, but applying any process to proactively work on improving the quality of your network gets you into a level 2. You start working and focusing that on application performance, and you can move solidly into a level 3 on the ITSM maturity model. Oops, sorry, skipped over a slide there. So today we're going to be talking about several of Augmantic's products. You can still apply the concepts we talk about today to any network monitoring system. Again, we will be focusing on Augmantic's products, both NMIS, which is our free and open source performance and fault monitoring tool. It sits kind of at the center or the hub of all of Augmentic's products. And then we'll also be touching on Opie Events, which is for operational automation. It's kind of a manager of managers. We'll be talking about Opie Trend, which is a predictive analytics engine, which bolts into NMIS. And we'll be talking about Opie Config, which does configuration and compliance management. And we'll be bringing those pieces in. But again, even if you're only using Augmentic's NMIS network monitoring solution, or if you're using a third party's network monitoring solution, you can still apply the same concepts we're going to talk about today to those pieces and get really good results from it. So for those of you who aren't familiar with the Augmentic application flow, you can do a kind of a high availability multi-tiered deployment if you need to, where you have multiple polling servers out in the field. They could be located geographically in separate areas. They could be at different offices. They could be on different floors of the same building, or just logically, you might have one poller inside a PCI DSS DMZ and one poller outside of it, and those two collect within their own kind of subnet areas, and then they report up to a common master. And you can have one or more master, and you can have multiple polling servers. So there's lots of different ways to architect a network monitoring solution with Augmentic solution set. If you have any questions, feel free to reach out to us. There'll be contact information at the end of the presentation today. So the next section is, how do I achieve that 50%? And that's really going to be kind of the big part of the conversation today. Before we move on, I'd like to ask another question, if you don't mind. So who is responsible in your organization for your network design, your architecture of your network? And I'd ask that you just pick one of the available pieces. Again, just take a moment. And I promise we've only got one more poll through this entire presentation, so I won't bore you too much with lots and lots of questions here. Again, if you could just take a moment. We're getting good response. We're getting about 67, 70% of everyone. Who is responsible for your network design or network architecture? All right, and we're going to go ahead and close that poll. Thank you all, everyone. So we got about 78% of the attendees responded. A large percentage, 71%, said my predecessor designed the current network architecture. I see one of the attendees mentioned that they contracted with an outside entity. Okay, all right. Very good. So the basic process, and now we will go into each of these items at the bottom of the screen, each of these numbered steps. We're going to go into these in depth, in detail, and I'll be switching from this PowerPoint over to the different Augmentic products and actually opening them up and demonstrating the different pieces and showing to you how they work and how they differ and how you can apply them on a day-to-day basis. But really, what our recommendation is, and this is something that we actually teach as part of our implementation course. So if you purchase or license one of Augmentic's products, even if it's just NMIS, we do offer implementation services and training services. We can even do on-site training for you and your team if you want to. And one of the things that we train during that is this process. And it's the concept of identifying a single responsible individual, or in larger organizations, a small team, what we call a task force, to follow this process and invest 3 hours a day of their time. It should be usually the same 3-hour window. We advocate that you pick a time, you block out a time every single day. It could be morning, could be afternoon, whatever works best. You can even split it, hour and a half in the morning, hour and a half, whatever works best for you. But assign a responsible individual or responsible team to follow this process, somebody who can follow it and track it and report back on what they're doing and how it's resulting and what they're seeing over time, right? But the basics of the process is really, really straightforward. And the first step is simply to be able to remediate the top 2 to 3 devices with performance issues. So every single day, you're going to create a list of devices that have performance issues over the last 24 hours, and you're going to focus on the top 2 to 3 worst performing devices. So which are the devices that have the highest CPU load? Which are the devices which have the lowest available memory? Which are the devices that have the lowest available drive space, right? Identify those 2 or 3 devices, and you do this every single day. You identify those 2 to 3 devices, you understand what's causing the issue, and then you remediate against it. The next piece is, again, this is done every single day, you remediate on the top 2 to 3 events of the day. So what are the events that are happening most often? And you look at it from an event standpoint, rather than a device standpoint necessarily. So you might say, well, gee, we're having a lot of node flap, or we're having a lot of node down, or we're having a lot of dropped packets. And looking at that issue and saying, what's causing this? Is this systemic? Is it something? Can we understand what the value chain is? What are the devices? How are they interconnecting together? Is it a waterfall issue where one device is causing a problem and that's waterfalling through? So, for example, we had a client who suffered from a lot of device flaps, and really at the end of the day, it came down to one router which was dropping a lot of packets on an interface, and that was causing connectivity during polling periods to the devices beyond that router to fail. So pings would fail, SNMP collections would fail, and then all of a sudden the blockage would clear up, and we'd get all the devices would come up. So they were going up and down and up and down and up and down. So while that same problem was occurring across dozens of devices, it was really being caused by one piece. The third thing you want to do is if you can deploy OP Trend, you want to enable it, and then you want to keep track of how it's gathering data over time. And again, we'll talk about this in more detail in a minute. But you'll get to the point where OP Trend, which works on kind of historical data that it's analyzing over time, and then it's working out trends, not just hour by hour, but also day of the week. So what's normal for this router's CPU on Monday from 9 to 10 might be different from that same device on Wednesday from 3 to 4. And so it's keeping track of those types of things. But you want to enable OP Trend and then be able to track through that. And the final piece is checking device configuration collection. And with that, what you're doing is you're really looking at OP config. Are your device configurations being backed up? Are changes to device configurations generating alerts? Are they generating the right types of alerts? Are you collecting configurations on all of the types of devices you want? And how can you expand that out? So those are the 4 things that this individual or this tiger team, right, this task force that you've got, should be doing every single day. And I'm telling you now, if you really apply yourself to this, if your team really applies themselves to this and does this every single day just for a month, right? And a month is really anywhere from 19 to 21 working days, right? Monday through Friday, 4.5 weeks in a month, generally speaking. So you got anywhere from 19 to 21 working days in a month. But if you do this for that month, if you do this for a calendar month and you apply these, I'm telling you now, you will see an improvement in your network performance by about 50%. How you measure that comes in a couple of different ways, right? It might be simply a reduced number of tickets being open. It may be kind of an audible return as far as improvement in VoIP quality across your network. It'll be the fact that you'll have less outages, you'll have less problems and congestion across the network. You'll start seeing improvements in your bandwidth usage also, because if you're reducing the number of errors and retransmissions that are happening, the load on your routers and your switches will drop. Their CPU and memory loads will drop. They'll come more in line, and so you'll see dividends very, very quickly. Just a week, 2 weeks into this, and you're going to see dividends right off. You keep going for a full month, and I'm telling you, it's going to be an actual positive impact on your help desk and on your team. So moving forward, let's talk a little bit about NMIS. So NMIS is Opmantic's free and open source performance and fault management tool. It handles all of your It's got your device database. It handles all of your device polling rules, all of your device models for what different types of OIDs and MIBs are actually collected from every single type of device. It also has all of your thresholding, all of your escalations, all of your notifications. It is a powerhouse of a network monitoring system. It's a fantastic piece. I've worked at several different managed service providers over the years, and in each place I've gone to, I've actually brought NMIS with me because of what a great job it does. And then, of course, you can expand on NMIS with a whole handful of bolt-on commercial modules. The first piece that we're going to talk about, and we're going to switch over here in a minute, is to start looking at a couple of different versions of the top 10. So this is Augmentic's NMIS platform. This is our base dashboard. I'm going to close out the event log and the network metrics and health window just so we have some room here. So there's two different types of top 10. The first comes in reports, top 10. Now you'll see that this one, even though it's a current report, is still looking back over the last 24 hours. You also have network performance top 10, which is slightly different. So the network performance top 10 option gives you just the last 15 minutes. So it's a much tighter spot check. You can also expand the one under reports into, you can reduce it to a 15-minute so it mimics the network top 10, or you can expand it all the way out to a week or a month. The concept here is to understand what are the it's hard to say the top worst performing things, right? But that's really what you're looking at. So you're trying to find the things which have the highest load. So for example, nodes by CPU load, you can see the highest load. Now the load here only happens to be 31%. You can scroll through these and you can look at interfaces by percent utilization, interfaces by traffic, the amount of traffic received and transmitted. Under the report side, you'll also get reports on ping loss, CPU loss, or CPU load rather. Top 10s by processor memory used, right? And now this just happens to be a routers only report, but you'll see the routers broken down by memory used. You'll see IO memory used, again, routers only. And then interfaces by percent utilization. And again, this happens to be over the last month. And then interfaces by traffic. And lots more pieces, top 10 errors and discards. And so these are the types of things that I would start looking into. Things like errors and discards, certainly down interfaces, and trying to understand why these interfaces are down, why we're having so many errors and discards from these different interfaces, and is that related to certain days of the week, times of the day, etc. So as a starting point, again, if you're just using NMIS or using some other network monitoring system, start and look at their top 10. Start from that point and see where you can go from there. The next piece you'd want to look at is service desk, alerts, events. From here, you can see all of the open events that are across NMIS, everything that hasn't closed out or matched out itself. Again, walk through each of these. You want to identify the top 2 or 3 devices generating the most events over time. So as I scroll through this, I can see here that B&E switch 1 has generated 13 events that are still open. So these events are still open. I may want to walk through these. They seem to have occurred at very much a very close time. Looks like we lost a whole bunch of interfaces here. And again, the point is not to try to tackle all of this, but pick the top 2 or 3, right? Pick the top 2 or 3 core devices first and address those. And tomorrow you'll pick the next top 2 or 3 core devices. And you just continue to address these issues every day, bit by bit. You're not trying to kind of break the entire glacier down in one blow. You want to chip away at it every day. The next report that's important would be reports, current, collect and update time. Now you can sort this by clicking on each of the column headers. So I'm going to click on collect time. And what you want to look for is you want to look for the devices that take the most time on collection and try to understand why they're taking as much time as they are. Now, the 2 devices here that are exceeding 20 seconds, these 2 devices, WMI Hell and Hell, that's actually the same device, but we're looking at it using 2 different methodologies. Hella is being collected using just SNMP, whereas WMI Hella is actually being collected using WMI as well. And that's actually a kind of an expected collection time because we're also collecting services on that device as well. But still, you want to check this report every day because you want to try to get a feel for how long does it take to run a collection on an individual device. Why are those devices so slow? Generally speaking, servers will take anywhere from 20 to 40 seconds to get all of the information back. But if you're checking this list every day and you know that certain devices take a certain amount of time and then suddenly they're spiking, so they're taking more time to respond, usually they tend to be overloaded. They'll also have low available memory. They'll also have high CPU. They may be running hot as far as the temperature of the unit goes. The other thing you'll want to do is sort by the update time. I'm going to reverse sort this so I can get this to the longest time. Now, NMIS updates happen once a day. Generally speaking, that's sometime after midnight, between midnight and 1. That's all based on server time. And collect time, of course, the base collect time is once every 5 minutes, but you can create much faster collection times now with NMIS 864G. We do have a variable collection time system where you can create different collection time requirements and then assign those to devices. So you might have some devices collected once every minute, others every 5, and you may even have ones collected just once every 15 minutes because you don't need that much, that high fidelity information. So now I've sorted the update time column, and you can see that some of these devices are taking well over a minute. We can go all the way down here. You can see all these devices are taking well over a minute, and some of them are taking more than a minute and a half. I would start on those devices and try to understand why an update is taking more than a minute and a half on these devices. Do they have lots and lots of interfaces that have to be pulled? Are they overloaded? Do they have too little CPU? Or do they have? Are they overtaxed on their memory, etc.? So again, it's all about using the built-in reports that you have, using the resources you have, sorting them by the top critical items, and then digging into those pieces. The next piece you'll want to look at is system config check, and then node admin summary. Sorry, I was on the wrong page. There we go. And then up in the top left corner, you want to click only exceptions. All right, so these are all the devices that are in NMIS that are having problems collecting. Again, that was system configuration check, node admin summary, and then selecting only exceptions in the top left-hand corner. So that's this little link right there. But this will give you information about the last time it was collected, the last update poll when it was done. You want to start looking at these ones that are all marked unknown. ICMP is working, false. So We've got to figure out what's happening there. Why aren't those responding to ICMP? Are we collecting on all these devices? Is SNMP working, right? What node model is assigned to these devices? You almost never want to have a default assigned to it. So digging into these pieces, this will really give you a list of devices that are having problems. And you may actually start with this page, right? If you're starting the process from scratch, you might focus here, because this will help get the polling system, make sure that the polling engine is collecting your information correctly. It's gathering everything it can. It's getting the sys-ID and the system description of the device. It's gathering that information, and that SNMP and ICMP are working, and that collections are happening properly. And if you look down the summary column, you'll see lots of good bits of information, not using automatic model discovery, last collect poll is unknown. So lots of good little pieces of data here. The last thing to look at, this is not necessarily something that has to be done every day unless you're just rolling out your system. But you do want to open up the NMIS runtime graph about once a week. Take a look at it and understand what information that it's providing to you. So this is actually telling you how long your collection periods are taking from start to finish, what the average and maximum times are for both your collection times and your run times, how many processes, how many NMIS processes, so NMIS can be multi-threaded, but how many processes or child processes on average are running, and how many are running on max, and then how many parallel processes may be running. So keeping an eye on this, looking out for any kind of spikes and understanding why those spikes are occurring. And of course, you can zoom in by clicking at the top of the graph. You can zoom into the graph. So you'll pop up this other window, and then you can zoom in. You can page to the right. You can move forward in time by clicking on the right side of the graph, and by clicking on the left side of the graph, you can move backwards in time. So next, we're going to expand on using NMIS. We're going to talk about one of Opmantic's commercial modules, Opie Events. So Opie Events is an advanced fault management and operational automation system. And I can throw out all kinds of things like machine learning and heuristics and all of those kinds of buzzwords. But really, at the end of the day, what Opie Events does is NMIS handles events one at a time as individual pieces. There is some correlation inside NMIS, so NMIS will correlate events. If one device is relying on another, and that's relying on another device, and a parent device drops off, you'll get one outage event for the parent and not everything downstream from that piece. So NMIS is smart that way. Opie Events, though, can build on it by doing things like correlation, blacklisting. It can do flap detection. It can handle event storms. In addition, it can actually do more than just notify you that an event's occurred. It can actually take proactive action. It can do things for you. So, for example, you might have a response that says, if a node goes down, I want to ping the node, and then I want to do a trace route to that device. If anything that you would do normally as an engineer, Opie Events can do for you. And it can take the results of those troubleshooting actions and store them with the event itself. So by the time you get notified that the event occurred and you're looking into it, Opie Events has already run all your usual troubleshooting pieces. It's even run custom troubleshooting scripts. It could even proactively do things like restart services, restart a server, push new configurations out to devices if you have opconfig as well. Anything you can do at a Linux command line, you can execute via Opie Events in response to an event. So building on that concept, let's take a look for a minute about additional information that Opie Events can give you regarding the health of your network. So we're going to leave NMIS now, and I'm going to take a look at Opie Events. We'll just log in. So this is the base NMIS or Opie Events dashboard, rather. You've got events by node over time at the top, really colorful display here. And then at the bottom, you have a simple table view of the top 10 or 20 or so events that are current and running through the system. What I want to call your attention to, though, is views, summary reports. Now, these are powerful. Opie Events will generate these summary reports automatically for you and store them in the Opmantic modules configuration file, opcommon.nms. You can actually configure it to email these reports out to your distribution list. So again, thinking about the concept of that assigned individual or that assigned task force, you would go to Views, Summary Reports, and I just selected the daily report. So this is a breakdown of all the events that Opie Events processed over the last 24 hours. So where in NMIS, I would go to multiple different screens and start taking notes, maybe copy and paste things into a text document and try to kind of keep track and organize things and figure out what my top 3 are. I can very, very easily come to this kind of a report in Opie Events and break down all the events across my network. So I can see event counts by node, so by device. So I can see that 16% of my events are coming from the Gold Coast router, 16% are coming from the Gold Coast server, and 16% are coming from the Gold Coast switch. If I addressed those 3 items today, I've got a host of problems fixed, right? 38%. A third of the problems across my network right now are taken care of. So think about noise across your network, right? Things like event flaps, node up, node down, SNMP loss, lost connection. All those types of events, it's noise, it's background noise. It's background noise that keeps you from focusing on real issues. It keeps you from focusing on upgrades and performance improvements to your network. So you start by looking at those types of events and silencing them, working towards fixing them, right? The next section down here, top 10 events by count. Same thing here, node down, node flap. Wow, interface down, deleted event, interface down. So someone plugged in an interface and then unplugged the interface. And we can break down event priorities by count, top 10 nodes and events by event count. Now, this is the one that I like personally because this compares not just devices, but the events that are running on those. So again, those top 3 things, the Gold Coast switch, the Gold Coast server, the Gold Coast router, there we go. Here are my top events across those devices. And if I focus on addressing those events and dealt with those today, tomorrow they shouldn't be here again, right? So we'd be looking at, what's the causal factor? Can it be remediated? Does it need more memory? Does it need more resources? Is it bad NATing? Is it bad pathing on my network? Do I need to provide better air conditioning to the rack or the server or the closet that device is located in? Is it low on memory? Does it need more hard drive space for more swap? So understanding what the causal factors of these things are, and again, maybe all 3 of these devices all connect into the Gold Coast router, or maybe they all share into one firewall or something upstream, and that device is causing the problem. And that's just raining down to these other devices. So addressing those pieces will go a long way to working towards, again, reducing that background noise, reducing that load on the environment and on your network as a whole, reducing those phone calls coming in. Hey, I can't save my file. Hey, I'm trying to browse to a remote folder or a remote directory and I can't get to it. All right, so same type of process, right, as what we've already looked at. Work the top 3 events and devices every day. Compare these to the NMIS top 10 list or OP charts top end if available. So if you have OP charts, if you've licensed OP charts, it has its own top end list as well. And then, of course, what you want to be able to do is you want to identify any troubleshooting procedures that could be automated. And again, you want to do this bit by bit every day over the first month. We've done a lot of implementations over the past 4 years that I've been here with Optech. I run the professional services group here in North America. And in many cases, what happens is clients ask us to try to automate for everything on day one, so that when they flip the switch and they go live with NMIS and Opie Events and the solution that they've purchased, that full response automation is in place. The challenge with that is that no matter how much you prep up front, it can be very, very difficult to actually understand and anticipate how NMIS might monitor your network versus whatever solution you have in place now. We often run into situations where an existing NMS solution may have been in place for years, and in many cases, events that NMIS or OP Events is seeing and responding to have been silenced in those older systems. And they were silenced because there was no way for anyone to fix the problem or address it or be able to do anything with that issue. And so they've kind of turned the volume dial from 11 to 2. And in our case, what we do is we advocate saying, no, leave the volume at 10, leave it noisy for the first month, and then start working to remediate the problems that are on the network. And you'll see the volume go down on its own. So the number of events that happen will go down, your background noise will drop off, and then you'll actually, when you see an event, it'll become a worthwhile event. It'll be something that you want to address and that you need to address because you've already worked through all the backlog of stuff. All right, moving forward. All right, we've got another poll for today. So before we start talking about OP trend, our next poll is, how would you characterize your company's internet bandwidth usage? So moderate, you only have a couple applications or a few users, so our internet bandwidth is good. You consider it average maybe, you have a few applications, file sharing, a few other things, but overall you're okay. Growing, moving everything onto the cloud or SaaS, so you're really eating up internet bandwidth usage. And the last one, this is the one I often pick actually. Absolutely out of control, bandwidth hungry fiends are all over the place. Everyone's downloading stuff, they're all on the network or on the internet all the time, and we can never buy enough bandwidth to satisfy people. So let's take a moment here. I'll leave this open for another 15 seconds. We got about 70% voted. Let's see if we can't get this closer to 100%. Again, how would you characterize your company's internet bandwidth usage? Moderate, average, growing, or out of control? All right, we're going to close the poll. We've got 71% replied. Thank you all very much. 60% said growing, so you're moving everything out to the cloud or a lot of applications out to the cloud, more requirement on SaaS and remote data centers, and 40% average. I'm actually surprised that no one considered their internet bandwidth usage to be out of control or moderate. So that's interesting piece. Thank you. So let's talk about OP trend. So OP trend is a SEDS-based algorithm that uses 26 weeks of trailing data. So NMIS and OP trend has to be up and running for 26 weeks before OP trend is fully kind of satisfied from a statistical standpoint and ready to go. You can turn it on earlier than 26 weeks, but 26 weeks is the window for it. OP trend gathers information from NMIS, so it uses NMIS's performance data, and it keeps track of things like average CPU usage, average memory usage. It'll keep track of each of your interfaces and interface bandwidth, bytes per second. It'll also keep track of errors and retransmissions. And what it does is it looks at each individual device in 1 hour windows of time on specific days of the week. So I gave that example earlier of, let's say a router on Monday morning from 9 to 10 would have a an average amount of CPU usage. And Opie Trend will track that router CPU usage over 26 weeks in that 1 hour window on Monday from 9 to 10. And it'll figure out what that average is over 26 weeks. And it will actually create a standard deviation window and say, this is the upper trend and this is the lower trend. And it'll give you 3 standard deviations. And anything that goes above or below that is outside the bounds of kind of normal operation for that device's parameter at that window of time. And again, this isn't just every day from 9 to 10. This is Monday from 9 to 10. And the Tuesday from 9 to 10 average would be different. It would be a completely different calculation. It's a completely different window of time. So what this does for you really is it allows you to replace, in a way, Augmantic's static thresholding system. So NMIS comes with device modeling for more than 10,000 manufacturers, 100,000 devices, right out of the box. Add a device to NMIS. It understands how to collect from it. It understands who the manufacturer is, what the model of the device is, all the different MIBs and OIDs that should be collected from that device. It gathers everything, tracks it all, and then pre-assigned to that model are thresholds for each of those different metrics that are being gathered and collected on. Now, those thresholds happen to be static. You can change them. You can absolutely update them. You can build them out over time. But what that means to you is that, let's say you have a router or switch sitting in an unair-conditioned closet, and we all know that never happens. I've never opened the door to a coat closet and found a switch stacked up on the top with a bunch of boxes all over it. But that device is sitting up there, doesn't have any air conditioning, maybe has low airflow around it, so its temperature is high, and as a result, it's dropping packets, it's having some errors, maybe its memory is running high as well, it hasn't been rebooted or patched in quite some time. Now, the thresholds that we have might put that device out of a normal operating condition. But for you, in your situation, because that device is never going to move, you're never going to get air conditioning in that closet, it's always going to run hot, it's always going to have high errors and drop packets, Opie Trend can look at that and say, oh, okay, I see that this is actual normal operating procedure for this device, and we're going to create a window of time, and you can see an example of that here. We've just got a very small sampling. This is a new demo server for us. It's only been up for a couple of weeks, so we only have a few weeks worth of data captured already. But you can see in the blue lines at the top and the bottom, that's the lower and upper control arms of that standard window of standard deviation, right? So remember the bell curve. And then the black line is the actual load, and the green line is the mean through that window of time. And in these places where it wasn't being collected, connectivity to that device, either the device was down or connectivity to the device couldn't be established. So these blue lines now become your new threshold. So you can actually turn off NMIS static thresholding and turn on Opie Trend as a replacement. You can have both running at the same time, side by side, and we actually recommend that direction. So lots of good opportunity here with Opie Trend, and it's not just the idea of the router or the switch that's in the closet, right? It's the concept of where's my load on my network? What time of day is normal? It's amazing to see that Opie Trend can not only tell you what's normal for kind of your CPUs and your memory and your TCP connections and your system processes, but it can also keep track of things like what's happening to my interfaces, how well are my interfaces being used. So you can actually use Opie Trend to help you do planning for long-term investment, what's going to happen across my network, for keeping track of how well bandwidth is being used. So you can see here we have the basics are being collected on this device now. This will continue to be built out over time. Let's see if we can find one here that's been in the billboard longer than a couple of weeks. Here we go. So again, upper and lower control arms for this time of day, and what the mean is, and then what the average utilization across that interface. The big concept here is, again, you're always trying to cut down the amount of background noise you have, right? So if you can track what's normal for your equipment and understand what's normal, not just on a day-by-day basis, but on an hour-by-hour basis. Is this normal functioning for a Friday at 6 p.m. in the evening, Eastern time? If it is, great. If it's not, is it higher or is it lower than what would be expected? And so you can both get rising and lowering alarms. So if you should be having a certain amount of traffic through an interface at a certain time of day, and that traffic drops off suddenly, you'll drop below that lower control arm and generate an action. All right. Last but not least, the fourth piece of the puzzle, the fourth piece of kind of focusing on improving the performance of your network is the idea that you can't just back up device configurations, right? That's really kind of networking 101, backing up device configurations. But you need to do something with that information that you've backed up. You need to try to understand, have there been changes in the device configuration? Are those changes authorized? Are those changes warranted? Are they something that should be allowed? Should those changes in a device's configuration generate an alert? Should someone be told when a router's enable password encryption has been disabled? So now the password is stored in plain language and can be seen in the CLI command. So is that important? Should that be something that someone should get a notification about? So with OP config, you can collect your device configurations. You can alert on configuration changes that you want to know about, that you want to maybe look into and determine if there's something that you care about. You also want to be able to use OP config to create kind of your custom configurations that are the way you want your devices to be, and then push those configurations out to your devices. So be able to reconfigure your firewalls, your routers, your switches, your hubs, all those types of devices, and make sure that you have a consistent configuration across all of your devices. Let's switch over and take a quick look at OP config. So OP config, again, you have a breakdown over time of devices and device changes, and we can easily kind of do a search. Let's just break down over the last, 30 days. There we go. And let's look at a specific, let's just look at running config. So this is going to pull back all the changes in this device. And you see in the bottom left-hand side that over the last 30 days, we've captured 4 different changes to the configuration of this device, just the show running config command. And if I drill into one of those, you can see that I've actually pulled the command, and we're showing inline the changes. So someone's configuring IP flow ingress for all the interfaces, and then configuring the flow exporter, where the source is, and then the destination IP address for the analyzer, which happens to be Augmentic's OP flow engine. So a nice little key-in, if you're using OP Events to handle your event automation, you can actually use OP Events and OP Config in parallel. OP Config can see a change. If the change is one that has to raise an event, that event can be raised from OP Config to NMIS. NMIS passes it to OP Events. OP Events can then be set up to automatically respond by pushing out or commanding OP Config to push out the correct configuration for that device. So again, if someone's turned the password encryption to off, you could actually push the correct configuration and restart that device if you needed to. So a couple of different concepts there. All right. So next steps, if you've followed those 4 steps and you've applied them every day for a month, I'm telling you now, you will see marked improvement in the quality and reliability of your network. But what's next? Let's say you finished a month. So after you get done that month, don't stop. You don't necessarily have to be working 3 hours a day every day and have a dedicated resource. But what if you cut it down to 2 days a week? Same dedicated resources, same people who are working together at that task team, only you can tone yourself down. Rather than 5 days a week, do it 3 or 2 days a week. Add in a few additional resources. You could add in Augmentic's OP reports. You could be looking at traffic reports, device performance, WAN and LAN reports from OP reports. You might add in NetFlow and IP fix analysis using OP Flow, right? Identifying top talkers, noisy applications, who's using your bandwidth, and what are they using it for. You might also add in, if you have a lot of Cisco devices, OPSLA, which is Augmentic's Cisco IPSLA solution. So with Cisco's IPSLA, you can actually generate traffic between Cisco routers. So you can actually test echo and jitter and HTTP and HTTPD load and response rates between routers and devices. So it's great to actually kind of build out this almost spider web mesh and get your actual network system to help understand the traffic that's moving across it, and then pull it all back into NMIS and be able to see how well things are doing. And then, of course, you'll also want to start looking at kind of shaping the traffic across your network and which types of traffic get what kind of priority. And of course, you'd use that with CBQoS, and that's monitored natively through NMIS as part of performance monitoring. All right, so that concludes today's presentation. I'm going to turn off recording now and open the floor for any questions.